limit of this expression here or this function. So first of all, let's take the numerator, which is the integral, with the limits 1 to x, ln e in exponent 4t minus 1 dt. According to the rules of the exponent, this integral we can write in this form: 1 to x, and the exponent goes in the front, 4t minus 1 times ln e dt. But ln e dt is equal with 1, and 1 times 4t minus 1 is a 4t minus 1. So this integral is going now to be a 4t minus 1 times dt. And when we evaluate this integral, we are going to end up here in this form. It is going to be 4. So let me write 4t squared over 2 minus t with the limits 1 to x. And now let me substitute those limits here. When we are substituting the limits, it's going to be 4x squared divided by 2 minus x, and here is a minus. And now we are substituting this lower limit, 1. 4 times 1 squared is 1, and divided by 2 minus, instead of the t, is 1. And when we are doing a whole work, 4 divided by 2 is a 2x squared, and here is a minus x. And 4 divided by 2, 4 times 1 is a 4, divided by 2 is a 2, minus 1 is a minus 1. So everything here is a minus 1. And now what we are going to do here, we are going, instead of this integral, what we have here in numerator, we are going to substitute with the 2x squared minus x minus 1. And now limit, so let me write with different color. Now the limit x goes to infinity. Instead of this integral, we write in a 2x squared minus x minus 1, everything is divided by x. If we divide everything by x, this is going to imply, so limit x goes to infinity is going to be, so 2x squared divided by x is a 2x, and minus x divided by x is a minus 1, and here is minus 1 over x. If we are taking individually each limit, so individual each limit here, for example, limit in 2x, so let me find here a limit x goes to infinity of 2x is infinity. If we take in then the limit x goes to minus 1 to infinity of minus 1 is a minus 1. And finally, the third limit here in this expression, in this function, would say, because this is a rational function now, which could give the hyperbola, and x to infinity approaches to infinity of minus 1 over x is equal to 0. And we are substituting everything instead of this limit here, so we can write so limit x goes to infinity of 2x minus 1 over x is equal with infinity minus 1 minus 0 is infinite. So this limit diverges. So this limit here, when we evaluate, so is going to diverge, is infinity. But now we can verify other limits. For example, when let's imagine a limit x goes to minus infinity, and let's say this is a f of x. So f of x, you can substitute this expression here and find out what it is. And the other thing is, for example, if a limit approaches the x from the right side to the 0 of f of x, so you can verify what it is. And the other limit, so limit x goes to 0 from the left side of f of x is equal with what? So you can verify those results, and you can find the right result in the same method what we did here.